Hello folks, in this video we are gonna find the derivative of a function by using first principles. There are other ways to find the derivative of a function like explicit differentiation and implicit differentiation, and they are more efficient for finding derivatives, but we are asked to use especially first principle for this version. First principle of differentiation help us evaluate the derivative of a function using limits. Let's remember the formula for first principle of derivatives. F prime of x is equal to limit as h approaches 0, f of x plus h minus f of x all over h. Notice that f of x plus h means take your f and in place of x, you use x plus h. Let's apply the formula. F prime of x is equal to limit h approaches 0. Now writing x plus h in place of x everywhere x appears. And minus f of x as is, all over h. Now I will use some algebra tricks here. First, I am expanding the parentheses. Now distributing the square of the parentheses, 5x squared plus 10xh plus 5h squared. Now expanding this parentheses, 2x plus 2h and minus 3. And here, a negative sign outside parentheses can be understood as the coefficient -1. I am using the distributive property to remove parentheses. Minus 5x squared minus 2x and plus 3. Let's simplify a little bit. 5x squared and negative 5x squared cancels. 2x, negative 2x cancels, and 3 and negative 3 cancels as well. Let's rewrite the expression. As you see, h is common factor here, and I'm factoring them out. This h cancels with the bottom h. Now it is time to take the limit. Limit as h approaches 0. It's basically plugging in 0 for h. And we got 10x plus 2. So derivative of f of x is 10x plus 2. We found the derivative, but what does all mean? 10x plus 2 is a function that tells you the slope of the line tangent to the curve at any point. Before start talking about the slope of the line tangent to the curve, let's remember the slope of a line. If you remember, there is one value for the slope of a line, and it can be calculated by using a few methods. But for a curve, the slope can be calculated for many points, and you can get many different results. So anywhere in that function f, the slope would be the number you get by using 10x plus 2 at any instant, any x. For example, to find the slope of the function curve 5x squared plus 2x minus 3 at the point x equals 2, we can use the derivative of f of x, which is 10x plus 2, by substituting x equals 2. So f prime of 2 gives us the slope of the line tangent to the curve at the point x equals 2. Let's substitute, and we got 22.